In the vast blue expanse of the ocean, a high-speed chase is underway. But this isn't your average hunt. A pod of dolphins is closing in on a school of fish, and they're about to deploy a strategy that for years had scientists scratching their heads. It's a maneuver so clever, so counterintuitive, it seems like they're using a secret weapon. Something that looks a whole lot like calculus. How can these marine mammals solve a complex physics problem in a split second? A problem that would stump even brilliant mathematicians? And what does it tell us about the hidden geniuses of the animal kingdom? To get just how smart this is, we first have to understand the problem. Dolphins are masters of echolocation. They send out a stream of high-frequency clicks and listen for the echoes. From those echoes, they build a detailed acoustic picture of their world, mapping out the size, shape, and location of their lunch with stunning accuracy. But some dolphin populations have developed a hunting tactic that, on its face, seems to sabotage this very superpower. They work together to blow curtains of bubbles, creating a thick, shimmering wall to trap their prey. It's a brilliant strategy for cornering fish, but it creates a massive physics problem. That dense cloud of bubbles should be an acoustic nightmare. Think of it like trying to use a flashlight in a thick fog. The light just scatters everywhere and blinds you. Bubbles do the same thing to sound. They are incredibly powerful acoustic reflectors that scatter sonar signals in every direction. The kind of standard sonar used on advanced naval submarines is rendered almost useless in bubbly water. The echoes from the bubbles create so much clutter that picking out the faint echo from a single fish becomes impossible. This sets up a paradox. Why would dolphins deliberately blind their most powerful sense right at the critical moment of the hunt? For years, scientists were stumped. Professor Timothy Layton of the University of Southampton, a top expert in underwater acoustics, remembers watching a documentary and being baffled by this exact puzzle. He knew that, from a physics standpoint, the dolphins should be completely lost in their own bubble-induced fog, unless they had evolved a way to process sound that no human engineer had yet dreamed up. Despite the acoustic chaos they create, dolphins using bubble nets hunt with remarkable success. They zip through their bubble traps, pinpointing individual fish as if the confounding bubbles weren't even there. It's a feat that seems to defy conventional logic. They are solving a problem that our standard technology has struggled with. This led Professor Layton and his team to a radical hypothesis. What if dolphins aren't just hearing the echoes? What if their brains are performing a complex mathematical operation on the sound itself? The idea that an animal could be using advanced math might sound like science fiction, but the evidence pointed towards a process that was, for lack of a better word, a form of natural calculus. The scientists proposed that dolphins might be exploiting a subtle difference in the physics of how sound interacts with bubbles versus how it interacts with a solid object, like a fish. This is where the idea gets truly mind-bending. The solution, they theorized, lies not in simply hearing the echoes, but in analyzing how the echoes change based on the clicks the dolphins send out. The hypothesis is that dolphins might be masters of something called nonlinear acoustics. So, what is nonlinear acoustics? Let's break it down with a simple analogy. Imagine you send out two clicks. The first is loud, let's call it a +1. The second is quieter, say at 1/3 the strength. When these clicks hit a fish, the fish acts like a simple mirror. It reflects a loud echo and a quiet echo, a perfect copy of what you sent. That's a linear response. But bubbles don't play by those rules. Bubbles are nonlinear. Now, this next part is a simplified way to picture it. Not a literal measurement, but it illustrates the idea. When the loud +1 click hits a bubble, it reflects a strong echo. But when the quieter click hits it, the bubble might respond disproportionately. Instead of sending back an echo that's 1/3 as strong, it might send back one that is much, much weaker, maybe only 1/9 the strength. The bubble's echo doesn't scale in a neat, linear way. This is the potential key. Scientists theorize that if a dolphin sends out a rapid sequence of clicks with different volumes, its brain could be comparing these distorted echoes. It might be performing an intuitive calculation, something mathematically similar to addition and subtraction, to filter out the noise. Think of it like this. The echo from the fish is consistent and predictable. The echo from the bubble is inconsistent and distorted. If your brain knows the rules of that distortion, it can create a mental filter. By essentially subtracting the distorted bubble echoes from the total soundscape, the clean linear echo of the fish could suddenly pop out. The theory is that the dolphin isn't just listening. Its brain may be instinctively solving an equation to cancel the bubble clutter and reveal the target hidden inside. It would be a biological sound editing system that operates in fractions of a second. This was a fascinating theory, but was it just a wild guess? To test it, Professor Layton's team couldn't exactly ask a dolphin to show its work. So they did the next best thing. They built a model. They created both a virtual sonar system and ran physical experiments in a giant water tank. They then programmed a system to process the returning echoes using these nonlinear mathematical functions. They ran a test. A small target, representing a fish, was hidden in a dense cloud of bubbles. When they used standard, linear sonar processing, the target was completely invisible, lost in the noise, just as physics predicted. But when they applied their nonlinear filter, the one inspired by the dolphin puzzle, it worked. The program successfully canceled out the bubble clutter, and the hidden target appeared, clear as day. This demonstrated that the concept was, at the very least, physically possible. Of course, this doesn't prove that dolphins are consciously doing calculus in their heads. It's far more likely to be an evolved, intuitive process hardwired into their neural pathways. But it does show that the mathematical principle is sound and offers a powerful explanation for their seemingly impossible hunting ability. The research was so compelling that it inspired the development of new man-made sonar. The question of how dolphins might solve this puzzle led directly to a technology called TWIPS, or Twin Inverted Pulse Sonar. This technology uses pairs of inverted pulses to achieve better target detection in bubbly water, the very conditions that confound conventional systems. So, engineers, taking a cue from the questions posed by nature, are now building technology based on this principle to find everything from sea mines to hidden electronics. The possibility that dolphins have evolved a form of biological calculus is just one piece of a much larger puzzle of their incredible intelligence. Their encephalization quotient, a measure of brain-to-body size, is among the highest in the animal kingdom, rivaling that of great apes. Their brains are incredibly complex and contain specialized spindle neurons, also known as von Economo neurons, which some scientists hypothesize are linked to social intelligence and emotional processing. Their social lives are just as complex. Studies have shown that bottlenose dolphins can remember the unique signature whistles, essentially names of other dolphins, for more than 20 years, which is one of the longest social memories ever recorded in a non-human animal. They engage in cooperative hunting, use tools, and have complex vocalizations that researchers are still working to decipher. While it's a controversial topic, some studies suggest their communication includes context-specific signals, raising tantalizing questions about whether they possess a system analogous to words. The story of the calculus-powered hunt is a powerful reminder that human intelligence isn't the only kind of intelligence on this planet. Nature has been solving complex physics and engineering problems for millions of years. Dolphins didn't need blackboards or textbooks. They had evolution and the relentless pressure to find their next meal in a challenging world. This may have driven them to develop a sensory system so advanced it performs calculations that we are only just beginning to understand and emulate. It leaves us with a profound and humbling question. What other mathematical secrets is nature hiding, just waiting for us to discover? What do you think is the most incredible example of animal intelligence? Let us know in the comments below. And if you want to keep exploring the hidden genius of the animal kingdom, make sure to subscribe.